by Marco Dorigo, year 1991, based on pheromone, okay? Pheromone, okay? Inspired by pheromone-based strategies of and foraging. And then for this case, for this topic, we illustrate using traveling salesman problem application. Okay, so after this, I give you example TSP. So how to solve traveling salesman problem using ant colony optimization. So we have cities like we discussed last class, previous class. For example, using GA kan, GA. So we solve TSP ni using GA. So today, same problem, but we solve using different technique. So we're using ACO, TSP. Okay, so after this, I'll give you the example how to solve using ACO. Okay, and then for ACO, we have many versions. For example, we have min-max and colony system, ACS, NQ, and so on. But for this case, I was using the classical approach. Okay, classical technique. Okay, the basic technique of ACO. And then ACO is classified under meta-heuristic population based stochastic approach. What does it mean, meta-heuristic and stochastic? Meta-heuristic mean heuristic about heuristic, but stochastic refer to what? Refer to what? Stochastic. Siapa tahu? Give some definition or brief explanation about stochastic. Siapa tahu? Kalau heuristic, you tahu kan? Heuristic. Ingat lagi tak? We discussed last previous class. Ingat tak heuristic apa maksud? Tahu ke tak? Hello? You all dah ready ke belum nak ada kelas, nak start kelas? Atau not ready yet? Senyap aja ni.
Ready, sir.
Dah ready belum?
Ready.
Okay, then so we discussed during tutorial stochastic and meta-heuristic, and then the detail of the algorithm can be found in Dorigo and Caro. This is the article related to ACO, so you can download from internet. And then the biological explanation for ACO, inspired by foraging behavior of ant, mean ant try to find the shortest path to find a food source from nest. Okay, so ant deposit pheromone along travel path which used by other ant to follow the trail. So using the pheromone, the intensity of pheromone, the intensity height mean the path, the probability, the chance to follow by other ants will high lah, based on intensity of pheromone. And then this kind of indirect communication with a local environment called steamergy. Okay, steamergy based on pheromone. and has adaptability, robustness, and redundancy to solve the optimization. So okay, the procedure. This procedure in SEO algorithm can be understood with analogy of real and behavior, and explore randomly in area near to the nest for food. Okay, first step randomly, and then another step based on intensity of pheromone. Okay, the first iteration random, the third iteration based on pheromone intensity. For example, we have path like this. This is the what we call the nest. Okay, this is the path. Okay, this is the food source. So we have two options, A and B. A and B. So some end using this road, another end maybe using this road. So for this case, A higher than B, the intensity. So the N will follow this road because of intensity pheromone. Okay, so we discuss detail after this in detail. And then and explore randomly in area near to their nest for food. They carry food to the nest as they find a food source. Okay. And then N has ability of producing pheromone. Pheromone is a chemical that gives sense of smelling during traveling. Okay, the smelling. So based on this, what we call chemical, and follow the path. We follow the same path based on the smelling pheromone. Pheromone enable N to create trail during return trip from food source to nest. Other N can follow the same path. Pheromone trail will be able to exploit the shortest path for the food source. Like this. So here we have location A and location B, nest and food. So 2N here start with equal probability of going on either path. So so the N on shorter path has shorter to N flow time from its nest to the food. That's why intensity high for A compared to B. Okay, because this one shorter than this one. A shorter than B. Then the density of pheromone on the shorter path is higher because of 2 passes by the N compared to 1. So so the intensity, this is the pheromone, the color, green color is pheromone. So the intensity for this one higher compared to this one. And then the next N will follow the intensity, okay? The highest intensity lah, the high intensity. Mean follow road A compared to road B for the next N. Okay, so that's why based on this what we call situation, we design algorithm that we call ACO based on biological situation for this case lah, using ACO. So we propose ACO to to calculate the optimize something, to optimize, for example, distance, for example, to optimize anything lah. So we're using based on this what we call inspired this situation lah. And then after some time, the shorter path is almost exclusively used compared to the B. Okay, A will be used. Okay, totally compared to B path. Any question before we proceed to next slide?
Sir, kalau macam dalam real world example, macam waste lah.
Macam waste. Kalau waste, actually waste we have many option kan. We have many option. For example, from A to B. So we have many option. Maybe from A go to node 1, node 3, node 4, and then after B, or from A go to node 2 before go to node 4, node 1, and go to B. So waste give you the precedent, okay? Which based on what? Kalau based on distance, okay, yes. Kalau based on timing, okay, maybe for road 1, road 1 compared to road 2, road 1 takes more time to reach compared to road 2. So maybe that one, the calculation based on traffic, not based on distance. But that one different ni lah, different calculation. Tapi kalau based on distance, so we can consider as a optimization, but I don't know ways using which technique, whether using GA or using just calculate the distance, then based on that the shortest distance or the shortest path, so the ways will produce ni lah, the result, a list of road. Depend. I don't know, but ways ada mirip lah dengan ni optimization. But the technique, how they solve the distance, I'm not sure. Clear?
Clear. Thank you, sir.
Okay, how do they do for natural end? Okay, this is the end lah. We have road like this, A and B, blue color and red color ni. Red color from nest and food. Okay. So A and B, since the road B is shorter than N on this path, will complete the travel more time and thereby lay more pheromone over it. Okay, I think no need to explain. I think you are dah faham. Same like this. We have the diagram like this, A, B, and C. So the distance between HDCBA ni, different distance. Okay. The concept of ACO, first, ACO navigate by random. Okay, the first step. And then, second step, the shortest path is discovered via pheromone intensity or trail. Okay, same thing. I don't need to explain. I think you all dah faham. The ACO, starting node selected at random, path selected at random for the first time, based on the amount of trail present a possible path from starting node, and then this is what we call the pseudo code for ACO. You tak faham tak apa. We study using example after this. So using example more easier to understand ACO. So just for your just for your brief explanation about SEO. So don't worry, tak faham tak apa. So after this we discuss again in detail. Okay, this is the serial code of SEO. Okay. First, for example, stopping criteria, cross-stopping criteria usually based on iteration lah. Iteration. How many iteration you set? Maybe 100 iteration, 1,000, 2,000, 1 million iteration, depend. Okay, stopping criteria. So, for example, you set 100 iteration, so the system or the system, the application will continue or will repeat 100 times because you set 100 iteration. So each iteration, the process will update the local trail. Okay, so here we have global and local update. After this we discuss. Okay, we proceed to example. Lagi senang. Okay, jap, I show you the example lah. Jap. You can download the example SEO journal calculation dekat you future. Okay, tengok kat situ. You all nampak kan? The share screen for applied journal ni, applied and computational mathematics, solving TSP using ACO. Nampak ke?
Nampak sir.
Nampak kan? Okay. Okay, first thing, you should consider this what we call formula, the probability. This formula. Okay, probability. And then the second thing, the toe ni. The toe ni mean the pheromone update. Okay, this is pheromone intensity. Okay. Tak faham tak apa, don't worry. Okay, you consider first time memang tak faham, tak apa. Okay, consider TSP problem. For the parameter we set, for this case 5n. Okay, alpha, beta and q. Alpha equal to 0.7, beta 0.7, q equal to 1, and number of iteration 5. And for the initial pheromone distribution equal to 1. Okay, what does it mean alpha, beta, and q? Okay, what does it mean? Alpha, beta, and q. So, we can refer this explanation. Okay, kat sini. Baca kat sini. Sekejap. Macam mana senang nak faham ni. Okay, I nak you all go through this article 5 minutes, then we discuss together. Sebab kalau I explain you tak go through lagi, macam you lost. Pergi je dulu. I give you 5 minutes to go through the article. then we discuss. Okay, sekarang buat. Download dulu. Okay, this is the first thing you must know. The n equal to 1 over d. The alpha and beta ni. This is the parameter, okay, parameter that control the weight of pheromone trail ni. Okay, the parameter. Then rho is pheromone. This is the rho is pheromone. This one. The pheromone. And number of n represented by m. Dah siap baca? Just go through aja. Tak faham tak apa. Baca aja dulu. Dah? Kenapa separuh satu kelas tak hadir? Kenapa? Kita ada 90 something, 90, 92, 93 student. 30 student absent. What happened? Ada test ke projek lagi?
Tak ada sir, tak ada test.
Okay, then for LK, mean the length of tour performed by NK and Q is a constant. Q for this case equal to 1. Okay. Okay, consider this what we call node Okay, cities. We have 5 cities. Okay, table 1 Tengok consider table 1. Okay, table 1. From A to B, 3 kilometers, for example. A to C, 6 kilometers, and so on. Okay, this one 0 lah. A to A, B to B, C to C, D to D equal to 0. So this symmetry punya ni lah table ni. I mean A to B equivalent to B to A. Okay. Okay. And then for first, based on this formula, okay, this formula ni, we need to calculate the ID ni. D is distance ni. Sorry. Mana pergi? One over D ni. 1 over D. Table 2, the H ni. 1 over D. 1 over D. IJ. D, the distance. Okay, for example, for A to B mean 1 over 3. So 0.333. Kalau A to C 1 over D equal to 0.16. Faham ke? Faham kan?
Faham, sir.
Faham. Okay, because we need to solve this formula first ni. The probability ni transition. The probability to transition this formula. So the n ni equal to 1 over D ni, n ni. Ni. So we need to solve this what we call this component. Okay, this component first. So that's why we calculate table 2. Okay, we calculate this we need to calculate the 1 over D ni. Okay, lepas we calculate, okay, then we need to randomly select the first city by each n. Okay, so for n1, starting point city B and city A, randomly. N2 start at city B. N3 start at city C. N4 starting point at D. Number N5, because we for this case we set only 5n. Okay, kalau we have 10n or 20n, so we need to randomize lah for 20n tadi. So for 5n, for n number 5 start at point E. Okay, for this first phase, first iteration. Okay, and then for initial iteration, pheromone intensity we set equal to 1 untuk yang first iteration, yang mula-mula, yang belum start lagi. So we put equal, okay, the number of pheromone distribution from A to B 1, A to C 1, same, except 0 lah, A0, A to A, B to B, so it is 0. Okay, this is the initial pheromone. Okay, and then banyak benda yang you need to calculate for ACO actually. And then for A to B, for the first iteration for n number 1, you tengok kat sini. A to B, the tau ni the pheromone distribution equal to 1, semua equal to 1 ni. Ini the tau ni. Tau yang ni. Faham ke? This is tau lah ni.
Faham, sir.
And then because we follow this formula, nanti you tanya kenapa nak kena cari this tau and so on, because this formula show like this. tau ni. Tu. Still the second component. The first component we calculate 1 over D. The first component tau. Tau T based on tau T alpha ni kat sini. Sorry, macam mana tadi? Ni tau T alpha ni. Ni alpha ni. Alpha kat sini. So, for this case, we set alpha equal to 0.7, beta 0.7, and Q equal to 1. Okay. Then, tau 1, kalau tau alpha 1, power of 0.7 equal to 1 jugalah. Okay. And then, cos mean the distance from A to B, 3, A to C, 6, A to D, 2, 1 over N, 1 over cos lah, 1.1 over 3, 0, and so on. Okay, 1 over N power of beta. 1 over N power of beta kat sini, you tengok the formula ni. Ni. Power of beta. So kalau ada tau alpha multiply 1 over N beta, so the formula, the value like this, the summation of ni, like this, and the probability after calculation, the probability yang formula, the first formula ni, yang ni, the first formula, like this. Faham ke? How they calculate? Okay, because we have 5 city from A, okay, consider kat sini. From A, tengok kat sini. From A can go to B, or C, or D, or E. Okay, that one for the second city. The third city from D, okay, can go to B, C, and E. From B, can go to C and E can go to C. So the total path equal to 17. You tengok the star sign ni kat sini. From the first step we have A go to B, or A go to C, A go to D, and A go to E. Okay, based on this distance, A go to D, this is the lowest. That's why from A we refer to D. So from D can go to B, so can go to C, and can go to E. We remove A lah because A occur only once. So from D to B, this one 2 kilometers, 6 and 6. So that's why we choose DB. And then from B can go to C and go to E. So we compare 5 and 3. So we choose 3. And then from E can go to C. So C equal to 4. So based on this cost, we calculate 1 over N and so on. Faham ke? Then the total distance from A, go to B, go to C, go to D, go B, E, C, and A. The total equal to 17. Siapa tak faham? The path for n number 1. Why we choose A, D, B, E, C and A? Ulang? Ulang ke tak payah?
Dia ikut probability yang paling tinggi ya?
No, the first, because we first random, we set for n number 1, starting point A. Okay, CTA. Okay, from A, maybe the n can go to B, can go to C, can go to D, and can go to E. Because we only have 5 city. Kalau we have 10 city, so ada banyak lagi lah option dia. Faham ke?
Faham.
Tak faham?
Faham.
Okay. And then, based on 4 option here ni, we have distance. Okay, from A go to B, we have 3. We have 6, 2 and 3. So our goal or our fitness function for this case is fx, if x, summation of summation of x, mean the total distance minimum. So minimum we choose the lowest value lah kat sini. So mean we have 4 ni. So the best option A to D because the shortest path kat sini. That's why from D after A go to D, so that's why yang the selection of third city ni we start at D. D go to B, C and E. So we compare pula 3 ni. So DB is shortest. So that's why we start at B, the next city, 4 city, B, C and BE. 5 and 3, 5 better. So EC, sebab E ni, EC, so 4. That's why the for this case, the path for n number 1, A, D, B, E, C and A. Clear? Tak clear? Yang lain ulang. Ulang ke tak payah?
Boleh ulang.
Ulang macam ni. Okay, I tunjuk macam ni. We have 5 city. Okay. Okay, consider n number 1. N number 1. N number 1 for phase 1 from A can go to B. Sebab kita ada 5 city je kan, can go to C, D and E. Ada lagi option? Tak ada dah. Betul tak? Kan?
Betul sir.
So from A to B, kalau awak tengok table kat sini, A to B, this one 3 km. Kalau A to C, tengok kat sini, A to C 6 km. A to C 6 km. Kalau A to D 2 km. Kalau A to E 3 km. So which one better? The best?
A to D.
A to D sebab the shortest. A to D. So we choose this, what we call this node lah. So from D can go to B, can go to C, and can go to E. Kenapa tak ada A? A tak boleh lah sebab occur only one for TSP. Faham tak?
Faham sir.
From D, okay, you tengok graph table ni. From D to B, tengok D to B, 2 km, 2. From D to C, 6 km. From D to E, 6, 6. So which one best? D to B kan?
Yes sir.
So from B, apa lagi yang boleh buat? From B can go to C and can go to E. You tengoklah BC berapa? B and C 5. B and C 5. B and E 3. So you choose 3. C. Tak ada dah option. You cannot use C. You cannot use A, B sebab the rule occur only one only. So E to C, E, C, 4. So for n number 1, the path that we should follow, A, D, after D, B, after B, E, and C. Clear?
Yes, sir.
Sama juga for n number 2. For n number 2, starting point B. From B, we can go to A, C, D, and E. So from B, go to A, 3. B to C, 5. B to D, 2. B to E, 3. So which one best?
BD.
D. So from D, can go to A, can go to C, and can go to E. Okay. So DA berapa? 2. DC 6. DE 6. So A the best. So from A go to C and E. AC 6. AE 3. So we follow 3. After E, C. E to C, E to C, 4. So for NB, we start at B, go to berapa? D, go to A, go to E, B, D, A, after A, E, after E, C. Ni, this is for N number N2. And the one N1. Boleh?
Boleh. Sir,
N3.
nak tanya, is that possible kalau ada dua best tu sama? Contoh,
Possible? Sebab random.
habis tu kita pilih yang mana? Kalau sama, the best.
Kalau best, kalau best, kita pilih yang the first one.
Oh, the first one lah. Okay.
Yang the first, yang mula-mula. Okay, then because after we decide we determine the best, what we call the best path. So we need to calculate 1/n. Okay, the distance n equal to distance lah, cos. Only cos, bukan cosine tu. This is cos. Cos mean the distance lah. And then just using calculator. Then the probability based on this what we call calculation. So the probability of the next city. Kat sini you tengok calculate ni. The probability of next city ni. Ni. This is the probability. Tengok the probability of the next city. Which one? This one higher than others. Okay. And then for n number 2, using the same what we call using the same method or approach, calculate 16 and 3, 16, 18, and 16. Okay, that one for first step. Second step, how to calculate pheromone distribution. You tengok, the first one, we set pheromone distribution equal to 1, standard. Okay, for the second iteration, the pheromone distribution will change based on this calculation. For example, A to B, you tengok A to B, kejap. Kejap. Mana formula pheromone distribution nak cari jap. Pheromone distribution. Ni. The pheromone distribution using this formula. Okay, using this formula. Okay. Kejap I cari calculator ni, kejap. Okay, take a break 5 minit. Okay, you go through the explanation tadi. Go through. Ada soalan ni. I nak cuba kira yang ni. Cari calculator jap. Probability jap. Kejap, saya pening. Saya kena print jap. Nak calculate ni. Pening sekejap, sikit. Okay. Sekejap. Okay, I nak you all sekejap. I nak you all go through for first iteration aja dulu. Yang second iteration ni tunggu sekejap. Saya confused. Bukan confused, saya nak kena make sure ni calculation dia betul. So, I kena print je, I kena print sebab I pening tengok. I pening tengok ni. I nak kena print. Jap, I print je. I print jap. Take a break jap. Sekejap. Okay. Kejap. Sekejap, I blank. Tiba-tiba blank, Masya Allah, subhanallah. A to D. Oh, okay. Okay, you consider the table. Tengok table Tengok kat sini. Okay. Sekejap. Okay, you consider the table. You tengok the what we call. Sekejap. Kenapa pula? Sorry, I pagi ni I can't think. I don't know why. I blank, you know. I blank. I don't know why. Sorry.
Tak apa.
Sebab I don't know. Sebab last semester I dah ajar benda ni. So no issue. Tapi tiba-tiba hari ni I not sure. I not understand why I can't think. I tak boleh nak fikir. Blank terus blank. Tak pernah lagi macam ni. Okay, take a break lah macam ni. For today, I stop kat sini. So we discuss masa tutorial. Boleh?
Boleh.
Boleh.
I don't know. Mungkin I
Boleh, sir.
tidur lambat kot semalam. Alright. Okay, bye. Assalamualaikum.
Waalaikumsalam. Take care, sir.
Yes,
So,
Thank you, sir.
Yeah, sorry ya.
Okay.